On this color sensor VI, we're going to use either the NXT color sensor or the EV3. So we have two versions. So you have to be careful which of these poly sensors you select. All right, so let me just run down this scenario here, okay, because it's really important. If you put the wrong one, it's not going to work for you. So if you have the big brown kits, you're in the honors sections, then you probably have the newer EV3 color sensor. So in that case, when you put that poly sensor in, okay, you're going to use the drop-down window, and you're going to use read EV3 color, and you're going to go to detect. Okay, and that's what I have up there. So I'm just going to visible item it, and you're going to see how it looks so similar. Now, if you've got the little bit older color sensors, those are the NXT ones. Those would be the kits that are red. You're going to put the sensor in again, but you're going to use the drop-down window, and you're going to go to read NXT color, detect color. Okay, so keep in mind that there's two different VIs or selections that you have to use on the poly sensor. Okay, both say poly sensor, but one is the NXT color detect, and one is the EV3 read color and detect. All right, so things are going to look a little different depending on which one you choose. All right, so let's talk about this case structure. Okay, first of all, when you use the poly sensor, okay, if you have the EV3 model, all right, you can right-click on this output, and you can go create an indicator. And EV3 this creates a VI here that's an indicator that actually converts this blue, which is a number, into a color word. All right. Now, if you're using the poly sensor off of the off of the NXT, and you do right create indicator, it does the same thing. Okay. So that's good. Now, the problem is if you just want to put this detected color on your front panel, we're all set. That's all this VI would have to be. Just jam that into a while loop and you're good to go. But what if you want to put the color out to the EV3 or NX? Well, everyone's going to have an EV3 monitor brick now. So what if you want to get that number and convert it into an actual text string? Okay, there's no way that I could find to go directly from here over to the poly display. So let me just show you. If I take the poly display and bring it up over to here, okay, it gives me an error because it's not text. I would have to go to write integer. So the best I could do would be put a number out there. Okay, but I want to put the actual name out onto the EV3 screen. Okay, so this is what I have to do. I'm going to get rid of this line, and I have to create a case structure. So let me show you what I did. Okay, so I'm going to put this back to write text, and I'm going to center it. I'll go to line 6, so I put that in, and now it can do text. So what I did is I created this case structure with a default black all the way up to brown. Now, I'm not sure if the NXT goes all the way to brown, but brown, even on the new EV3s, doesn't detect very well. Most of the time, when it looks at brown, if it's a dark brown, it's going to come up with black anyway. So don't worry if you don't have brown. But let me show you the easy way to create a case structure that could do this kind of thing. Okay, so let's take, let me take the EV3 one. Okay, and I'm going to just put this into a case structure. So let's come on up here, programming and I got case structure. So here's my case structure. Okay, so right now it's on a true false setup, but the easiest way to get the right cases in here is to just click on here and connect the question mark, which is known as the case selector. Put that in there. And right now, Labview's smart enough to know, hey, one of the choices is black. In fact, the first choice is black. Now what you do is just come up here and add a case after, adds blue. And just keep doing this until you see a blank. Okay, then it's going to go to green. Whoops. I guess I can do it here. Whoop. Sorry. Add case after, I'm up to yellow. I got just a couple more to go. Add case, I got red. I've got white. I'll try it one more time. Add case after. It does come up with brown for both detectors. If I add another case, it comes up with blank. So I've exhausted the entire list of things that might come in here. So I'm going to right click and I'm going to delete this last case. So now my cases are no color, which is the default, black, blue, and all that. All right. Okay. Now let me just make this bigger. What I can do is I'm going to put a text string in each of these. Okay. And so I'm going to right click, go to programming, go to string constant. So when there's no color, I want to put out the message no color. And I'm going to just bring that and make a tunnel. Now when you see the tunnel is an open square without fill, that means the other cases don't have anything in them yet. So you'll have to go to each of these, do the same thing. And then this one's going to be black. Bring that to the tunnel. And then you do that for all the rest of these. So up here, I've done that for all of them brown. So what we've effectively done with our case structure is we've taken an integer that the case structure is smart enough to know brown and all, but the poly display isn't. So we do this little bit. So let's just, I'm going to run this and test this out. So I'm going to go tile left, right, and I'll use debug mode so we can see the colors in here. Now keep in mind this color sensor is not absolutely perfect. You go on certain shades of yellow and it'll come up with blue because isn't blue made, I don't know. No, I think it's green is blue, blue and yellow. All right, well I'm over a Reese's peanut butter cup package right now and I'm going to go run. So hopefully this is going to, it gives me red. Well, it's kind of reddish orange. Now I'm going to come over a black mouse pad. Now I'm going to point it up. It says no color. And my EV3 screen is also reading what you're seeing on the detect color. So have fun. So on our move until touch, you have a little bar and which is connected to where if the front of the robot, your tribot, bumps into something, there'll be a touch sensor that gets depressed. So what we want to do is we're going to set up a while loop so this runs forever. We're going to put just a slow speed into it. Now if you don't put a motor into the move motor, all right, you look up in the context help here. I think I can drag this over. The context help says if motors is not wired, the default behavior is to move Lego motors connected to all motor ports. So since we're going to have two motors, instead of having to put two speed controls, we can just not wire anything and it's going to send something out to all of them. The other one is you're going to use this poly wait because you're going to turn your motors on and then you're going to wait until that front sensor, touch sensor, is pressed. So there's a wait. So you bring a wait for. You can put a time delay in there, or what we're going to do is we're going to wait for NXT EV3 touch until it's pressed. Okay? So you're going to do that. Then you're going to break. Okay, that comes into stop motors, and there's two ways. You can brake abruptly or you can coast to a stop. We want to brake abruptly. And then the last thing is a poly weight, similar to the first one. Okay, and that is a wait, but this time we're going to wait for a release of the button. Okay, so we're going to come here, we're going to wait here until the button is pushed, then we're going to stop the motor. We're going to keep the motor stopped until the button is released, and then the little unit is going to go again. All right, so that is a nice little routine. Move until touch, move until dark. Okay, so we're going to use this with our light sensor. I got move until dark. Okay, so I've got the light sensor. It's in port 3. We're going to scale that value. I'm going to just clean up this wire here. Clean up wire. Okay, so this is, we've got an indicator telling our light value, our scaled light value. It's going to go to the front panel. That value is also going to go to the poly display line 1 so we can see it. We have an indicator. I should clean up that wire. Move that down maybe. So I got an indicator that's going to tell me what level of light I want to stop the motor. So if you're less than 50, we'd stop the motor. And you can put anything from 0 to 100. But just know, I mean, if you make this too high a number, you're just always going to be stopped, and if you put it too low, it's just never going to stop. So 50 is good. All right, so you put that into there. We've got our case structure with just plain true false. So the true case, you're going to do a stop the motors. Now I don't put, if I don't wire in any motor port, it's going to stop them on all of the ports. I'll confirm that over here. If motor's not wired, yeah, they're all going to stop. Okay, so that's the lazy person's way of doing things. All right, on the false case, if you're not less than 50, that means you want to keep going. You're going to keep moving your motors, and you're going to do a speed of 25. So that's a nice little routine, and you can go ahead and run that. Okay. Now our last VI is actually obstacle detection. So this is going to use your Sonar detector. So I'm going to open obstacle detection. I've got a newer one here, corrected. This says fall 2014, but I have spruced it up a little bit for 2016. The only thing I'm going to have on the front panel is obstacle distance. So let's take a look at this. All right, so I'm going to use a Sonar. Now you got to be careful because there are two versions of the Sonar, one for EV3, one for NXT, just like we talked about for the color sensor. So when I come in here, remember if you want the smaller menu to come up, you target to your NXT first, then we get the small menu. All right, so let's go to I/O. We're going to go to sensor. And I'm going to make two of these. Okay, so the one on the left is if you have the EV3. Now that's a Sonar sensor that got a black face and it lights up. All right, if you've got the NXT, I have NXY. NXT one, it works just as well. It just looks a little different, and we need a different version of the VI. So for the EV3, you got to come down here and you have to say read EV3 ultrasonic, and we want to be in centimeters. Okay. If you're on the NXT, then you're going to come down here and you're going to read NXT ultrasonic, and it just says Sonar. So you see what I have here was for an NXT thing. So hey, your instructor's out here you know, testing stuff out for you. And notice the default on the NXT is in centimeters, whereas on the EV3 you can choose different units. All right, so that's one thing. Everything else is things we've done before. Now this time I actually put motors on B and C, but then this is an older VI, okay, that is no longer there. So instead of doing that, I should do edit, undo, edit, undo, edit. Can't undo? Oh, nice. Okay, there it goes. All right, so this is an older VI. It still works, but you won't be able to find it. So yours is going to be this. So I'm going to go replace all palettes, IO, and I'm going to put move motors. Okay, when I do that, it's going to end up looking pretty much the same. Now it still retains this. Yours isn't going to look like that anymore. I'm just going to delete that. We want to put this to constant speed. So when you do your two motors and create your constant, it gives you this thing, which is a little bit different. Okay, so you're going to want to put on 25% ports B, and this one you're going to want to put C. So B and C are both going to be going at a speed of 25. The reason why it says power here 25, in fact I don't even know if that comes up anymore, because I think it just confused people, but speed, there's actually two speed ports here. Okay, so let's just talk about the context help here. Power speed 1. For motors that do not have built-in encoders, you must connect motor encoders to move with speed. Lego motors have built-in. Okay. You can specify whether to use a constant power. Okay, got that. Inputs, motors, power speed. Specifies the amount. The default value is 75. Okay. So we got to really put 75 into each of these. So I'm going to create a constant. Actually, I don't want 75, I want 25. I want to go slow. So I'm going to put 25 there, and I'm just going to wire this one up here. Okay? So both of those are going to go at a speed of 25. All right. Then on the true case, all right. So in this case, I'm going to change this a little bit, because what I want is I want C to go at minus 25, and I want B to go positive 25. That means the two motors are going to turn in opposite directions for 1 second. So this will turn your robot about 25 degrees. Now the way you're going to do that now is in the following way. You could do it with two separate motor ons, but we could do it with one as well. So let me show you. Okay. The poly wait, it's going to wait for time. You know where to get that. You come into I/O, you come into wait, and there's one for time. And then you can just create a constant. All right, so over here we can just put a move motor. We can put one move motor in, and I'm going to come up here and create the constant, and I'm going to put in, the first one is going to be motor B, and the second one is going to be C. Okay, so red is B. So I want to put the power for B to be 25, and I want the power for C to be minus 25. The range of values that you can have on these are between minus 100 and positive 100. Okay, what happens if I put a visible item label? Power speed 2, power speed for 1. Okay, so I am going to run this thing, and I've got Sonar here. Since I'm running it on an EV3, I'm just going to switch it over to read ultrasonic in centimeters. And let's give this a shot. Now the reason why my VI wasn't working is I had this stuck on constant power, and it needs to be on constant speed. Okay, so for the speeds to work. All right, so now I'm working really well. When I come up to something, it reverses the direction for 1 second, and then it goes off on the right speed.